This is a video on how to analyze experiments or results by using the VIT Online Randomization test randomization. For this purpose, we take this following task: design an experiment to investigate if stretching can have an effect on arm strength. You may use textbooks as weights, and we need to measure the time in seconds your experiment subjects can hold the textbook with their arm extended at 90 degrees from their body. Your treatment group is the group that stretched before holding the textbook. Your control group is the group that did nothing before holding the textbook. So we carry out the experiment and record the data into an Excel file, like we did here. So we record the class or the teacher who's teaching that class. The two groups are stretching and non-stretching. Time measure in seconds, and then convert that into seconds, and then just seconds, and then save this file as a CSV file where only the seconds come up, the teacher, the groups, and as you can see here, stretching, non-stretching, and how many seconds they have held up their textbook. Now, this file haven't been saved, and this is very important that we save it in as a CSV. We go to the VIT Online website, which is, the address is this one at the top here, and choose randomization test. Now we choose a local file, and that's the CSV file with the results of the experiment we have done. And we've got the CSV here. And now we select group, which is stretching, non-stretching, and measure time. To select both, while clicking on the measure time, here you need to press down Control. So now that we've got both and the medians, so stretching, not stretching, that's the time in seconds, the medians. So let's press Analyze, and over here, instead of mean, we need to select median. All right, and these are actually the medians for stretching and non-stretching. Now let's press Pre-calculate Display, and we select 1000 under random groups and 1000 re-randomization distribution, and then we go Go. And we want to show the tail population. Which is 25 out of 1000. We can see it down here. I'll try to make this slightly smaller so we can see better. All right, that's the distribution, and we've got 25 out of 1000, which is 0.025. That means we've got 2.5% of the randomization with a difference greater or equal to the difference we got from our experiment, which was 103 seconds. You can see it over here. Now, from that, we want to know that the two medians are far enough apart from one another that we can be reasonably sure that the difference is real, being caused by the treatment and not just random chance. We need to decide if we have enough evidence to say whether or not there is evidence that the difference in medians is possible by chance alone. To find this evidence, we look at the probability calculated by the randomization test. The cutoff point is 0.1 or 10%. So if we have a value smaller than the cutoff and our value was 2.5%, which is smaller than 10%, then we do have enough evidence that the difference between the medians that we see is not due to chance alone. If our value was greater than 10%, then wouldn't have had enough evidence, and the difference between the medians that we see may be due to chance alone. So in our case, and I go back to the display, where only 2.5%, and that's this bit here, this dots here, 2.5%. Everything else is to the left. So only 2.5% have a difference greater than 103 seconds. And that's pretty much it. Thank you for watching.